Hi guys. So I'm gonna do a little video with you, just going over the stuff that is the topic for you this week in Edgenuity. So we're doing inferences and predictions. So you guys have done this. We've done this in class. And we're looking at sample size and an accurate prediction or inference taken from sample data and sample space. So we want to make, in order to get a well-rounded, accurate prediction, we need to have a few things in place. We need to have a big enough sample size, because the bigger the sample size, the more accurate of a finding that you're going to get. So, I'm going to read through this problem and then we'll work through it together. So when Jim surveyed 5 6th grade students at the community skating rink, he found that only 1 out of the 5 had completed the science project. He knows that there are about 160 6th grade students in his community, so he infers that around 32 students have finished their science project. Is this a good inference? Well, let's look at it. He surveyed 5 students out of the total of 160. So the first problem is his sample size wasn't big enough. And then he only surveyed people at the skating rink. So that is not a good, it doesn't hit all of the people in the community and give them the same opportunity to be surveyed. If you didn't go to the skating rink, then you didn't get polled. So that's the second problem, is he only asked people at the skating rink. So we want to know if his inference that 32 students out of the 160 completed their science project. So we're going to set up a proportion just like we've done. So we've got 1 out of the 5 students that he surveyed had completed their science project. So how many students is that out of the 160? So we know how to solve a proportion. We cross multiply and divide by the oddball, or we set it up like this. 5x equals 160. Then divide by 5, and we get 160 divided by 5 is 1, bring down the 0, so it's 32. So his numbers are right. X equals 32. So that was a good inference in that aspect. So now let's look at our options, answer choices. No, Jim did not make a good inference because his sample size is too small and may be biased because he only asked students who were at the rink. Well, we agree that his sample size is too small. He only asked 5 students out of the total of 160. So he's not going to get a very accurate sample. And also, he only asked people at the skating rink. So he didn't include the rest of the people that don't go to the skating rink. So no, he did not make a good inference there. And let's look at our other options. No, Jim did not make a good inference because his sample size is too small and 32 is not the same proportion to the population as 1 to 5. Well, that's wrong because we saw that X is 32. So that's wrong. His sample size is too small, but 32 is proportional. And then yes, Jim made a good inference because 32 is the sample proportion to the population as 1 to 5. That is true, but he didn't make a good inference because he didn't have a big enough sample size. And it was biased because he only asked people at the skating rink. And then yes, Jim made a good inference because most students at the rink were 6th graders. Well, we don't know that. And he still didn't ask enough. He didn't survey enough to get a good enough sample size to make an accurate prediction. So your best choice there is the first one. No, Jim did not make a good inference because his sample size is too small and may be biased because he only asked students that were at the rink. So when you do sample sizes, you have to look at the total that were surveyed out of the total number that there are. And there needs to be a big enough sample size that you can make an accurate prediction. I hope that helps with this week's work. And if you need any help or have any questions, text me, call me, comment in the Google Classroom. Talk to you later. Bye.